A very good evening, everybody. My name is Prerna, and I represent the enterprise team of Cognixia. On behalf of the team here, I welcome all of you present here today. I hope you are safe and doing good at your homes. Thank you for signing up for the session today. Today will be about the digital transformation that happens through machine learning. I'll quickly introduce what Cognitia is and hand over the podium to our trainer to take up the discussion from here. Cognitia happens to be a leading digital talent transformation company, and we cater to over 450 clients over the globe. We are essentially partners with most of them for their training needs. We have a pool of 7,000 plus trainers and have been successful in training more than 130,000 professionals over the globe. Our forte lies into the digital technology space, one of which will be covered today, and there are many more. We absolutely support our clients on delivering these sessions through virtual training mode as well as the classroom mode. Some of the centers of excellence are being flashed on your screens right now. About our speaker today, Mr. Abhay happens to be having an experience overall of more than 18 years, out of which he has been into the learning space as a corporate trainer for over 10 years now. He is a champion in Linux, Python programming, data science, machine learning, R programming, and many more. Abhay, you can take up from here, and I will have a quick conversation towards the end of the session.
Thank you, Prerna. Welcome all. And as Prerna told you, like I have been into IT industry for almost 19 years. I started my career in 2001 after doing BCA, MC, and MBA from Narsee Monjee, Mumbai. I worked for 10 years for various organizations like IBM. I worked for 4 years. I worked for G Capital for another 1 year. Then I worked for HSBC Bangalore for another 2 years. And my last job was with United Health Group Gurgaon. I worked there as a data scientist. And I've delivered more than 1500 plus trainings on Unix shell scripting, Python programming, Python with machine learning, with data science, R programming. I'm certified SAS professional, I'm certified Unix professional, and I'm certified AIX professional. So let's start off for the day. And we have a lot of things in the agenda today. It's a 2 hours program, and I'll be taking a 10 minutes break after 1 hour. I'll keep you all of you in the muted state, and I'll give you a time to ask questions after, let's say, 45 to 50 minutes. And I'll have a question and answers in the last of the session. So as the number of people are quite high, more than 500 plus, so I cannot answer all the queries, but definitely I'll give you the email ID of Cognitia so that you can send a mail to them and you can get the reply on your emails. The agenda for today's session is why Python is more useful in machine learning field, what makes Python so popular. So it's a buzzword these days, Python with data science, Python with machine learning, Python with deep learning. So I'll explain you all these concepts in brief. What are the major differences between Python and R, and why Python is preferred over R? So R and Python are both very competitive languages, and many of the organizations are working on R for statistical purposes. Now, I'll explain you why Python is more popular as compared to R. What are the industrial trends of the machine learning? What people are doing with machine learning and why they need it? How machine learning can add value in different sectors of the business? How data science and machine learning fit with the organization existing analytics. So a lot of companies are doing analytics, and how machine learning is fitting into the analytical portion of the organization. How organization personalized needs driven by data science and machine learning. So how organization is different organizational structure, like a telecom domain, like a banking domain, like a manufacturing domain, how they are utilizing machine learning in their day-to-day services. What are the different types of machine learning? So they are broadly classifying three categories of machine learning: supervised, unsupervised, and reinforcement learning. What are the use cases of the machine learning in BFSI sector, automobile industry, healthcare industry, telecom industry, or retail industry? What are neural networks? So we talk about briefly what is neural network, how it is similar to the neurons of our brain. What is deep learning? So neural network comes in the concept of deep learning, how they are trained and deployed in practice. Some popular deep learning frameworks like TensorFlow, Keras, PyTorch, and Caffe. So these are the libraries for deep learning, and how deep learning is different from machine learning. So might be confused about these terminologies. What is data science? What is data analytics? What is machine learning? What is deep learning? How they are related to each other. So I'll explain all these concepts to you. How GPUs are used in training deep learning models. So this is the agenda for our 2 hours. So I'll be going slow and steady and explaining all these things to you. Now the question comes, why Python is so popular and who is using Python and for how long they have been using. So if you see the today's market trend, all the market leaders today who are the big companies, who are Fortune 500 companies and doing really good, they have been using Python for almost 10 years now. So many companies are opting it now, being because of many popular libraries in Python. like SkyPy, Pandas, NumPy, and Matplotlib. But these companies, which you see over here, they have been using Python for almost 10 to 12 years from now. YouTube is using Python for largely using for sharing their videos and the contents on the internet. Google makes extensive use of Python for the web search engine. And the web search engine is so dynamic in nature. Suppose you write president of, you'll get automatically USA, India, and other countries. So predictive analysis are also there. So if you go to Google taskbar and just write down any keyword, you'll get the help over there and it automatically get filled up. So this is the concept of deep learning which will come in forward. So Google has been using Python for web search engine for the long time. Dropbox storage services codes both in server and client side is using Python for a long time. Raspberry Pi single board computer promotes Python for educational purposes. BitTorrent is using for sharing file from one machine to another. NASA is using for programming tasks. NSA is using for cryptography and intelligence analytics. Netflix is using for recommendation engines, and other companies like Amazon, Flipkart, they have been using for recommendation engines and market basket analysis. So all these companies have been a market players for a long time, and they are using Python for a long time. Now, why we use Python in field of machine learning? What is the basic need of Python, and why companies are switching from Java, C++, or any other programming language to Python? One of the basic reasons is that it is simple and easy to learn. It is more like a syntactically English-like language. You don't have to learn a lot of jargons over there. You don't have to learn a lot of keywords over here. Mostly it's an English-like language, and anybody and everybody can learn Python very easily. You might have observed, like in CBSE board in 10, 11, and 12, also Python has been incorporated. But in older times, in my times, like C, C++ was there, which was quite difficult to understand syntactically and programmatically. You need to take care of the memory addresses, you need to take care of the types of variables. But here in Python, it's very simple to use. Python automatically understands what is a variable type. You don't have to declare the variable type. For example, I'll show you a small demo over here. So once you install Python in your machine, you get a tool called Python idle, which is an interpreter of Python. So Python is both interpreted and compiled programming language. So interpreted languages are those which executes line by line, like for example, Unix shell scripting, Perl scripting, and other scripting languages like JavaScript, VBScript. And programming languages are those which are compiled environments like C++, like C programming, like Java programming, where whole code is converted to machine level code. Even if the single error is there on the 90th line out of 100 lines of code, code will not execute. So I was talking about there's no declaration required in Python. Suppose I declared name equal to John. Suppose I declare a name equal to John, I don't have to tell it's a string type. If I say type of name, it is going to automatically tell me it's a string type. Suppose I say a equal to 10, and type of a definitely is going to be an integer type because it's an integer. Similarly, if I say b equal to 10.22 and say type of b, it is going to say it's a floating type. So we don't have to declare a data types in Python. It is automatically inbuilt in Python that automatically understands. Suppose you say x equal to 5j plus 10 and type of x, it is going to be a complex number. Now, in other programming languages like C++ and other programming languages, you have to use operator overloading to use plus symbol. Suppose I add 10 plus 10, you get easily 20, which is quite possible in other programming languages. But if you talk about John plus space, John plus space and plus Matthew, you'll get a concatenated string. The plus symbol is used as a concatenation symbol over here. So it's quite easy to understand, as you can see here now. Similarly, there is a print statement. Suppose I say a equal to 10, b equal to 20, c equal to a plus b, and I simply say print sum of a and b is c, you usually get the answer as 30. So syntactically, as you can see, it's quite easy to understand. Similarly, memory collection or garbage collection is not a task of a programmer. Like in C programming, if you declare 100 variables, you need to tell, okay, what variable, what space it is taking and cleaning up the memory. Suppose I say equal to 10 and b equal to 10. So the id function is going to tell you the memory address of a, id of b is going to tell the memory address of b, and you see both are same. So when the values are same in Python, the memory addresses are same. So it is automatically doing garbage collection. We don't have to worry about a memory. And that's the reason you might have observed Python has been using on Spark and Hadoop systems quite extensively. Spark and Hadoop systems are ecosystems which can handle terabytes of data. And the Facebook servers or a Twitter server or a LinkedIn server or a Facebook server or or a Amazon servers, you can see billions of transactions are happening day by day basis. And it's really impossible for any traditional programming language to cater that huge amount of data. And Python is quite easy to handle that. Now coming back to the slide, so as you can see, Python is very simple and easy to learn programming language. Syntactically, it's not difficult. It's an open source. You can easily download from the internet. If you go to piper.org, you can easily download Python, or you can go to python.org. You can easily download Python from there. It's an open source and it's platform independent. You can install Python on a Unix flavor, on a Linux flavor, Ubuntu, Solaris, HPUX, CentOS, any kind of a Unix and Linux operating system. You can install Python very easily, and code is not changeable. If you install Python in Unix and write down the code over there, you don't have to change the code on Windows except the paths and everything, because in Windows we use backward slash, but in Unix we use forward slash. So only the path and file names were going to change, rest everything remains same, and there is no need of change of code from one platform to another. It's a very high level programming language. You don't have to worry about the low level details like how to convert to machine level language, how to convert to a bytecode. It's a very high level programming language in terms of object oriented programming. So all the concepts like encapsulation, inheritance, abstraction, polymorphism is already there in Python. It is very much portable. As I discussed, you can write down a code in Unix, transfer it to Windows, from Windows to Macintosh, Macintosh to Solaris, and the code is not going to change. It is platform independent programming language. Now, why Python in the field of machine learning? It supports different programming paradigm. It is helpful to work on procedure oriented programming. Like in C programming, we define functions and we call the functions over there. In object oriented programming, we define a class and we can create an object. We can do inheritance, we can do abstraction. So both the ways people can do the programming. So people who are interested in object oriented programming, they can go for object oriented paradigm. People who are interested in procedure oriented programming, they can go for procedure oriented programming. It is very much extensible. Python code can invoke C++ libraries. It is very much integratable with the other programming languages. If you want to work through AWS environment, if you're working on Python and you want to connect to AWS environment, you can use Boto3 library, BOTO3. So many libraries are there which is connecting to the external sources and getting the data from there. Similarly, Pandas libraries can get the data from any of the external sources, maybe a Parquet file, Feather file, Hadoop format file, text file, Excel file, CSV file. So you can import the data from any of the external sources. Now, why Python is so popular these days? Because of many reasons. It improves programmers' productivity. How? Because Python code is one third the lines of code written in C, C++, or Java. Suppose you write 100 lines of code in Java. In Python, you just need to write 30 lines of code to do the same thing. It is extensive support of libraries. There are 65,000 libraries in Python. If you don't go to website piper.org, and you'll see, if you write on any area like cancer patient treatment, or you write automobile industry, or write aerodynamics industry, manufacturing industry, you'll see hundreds of libraries there contributed by the open source community. And you can download those libraries and you can use the functionality over there. You don't have to reinvent the wheel. Suppose you want to do a lot of statistical work, so you simply need to import stats library and start working on statistical operations. If, for example, if you write from SciPy import stats, so it is a library, SciPy is a library for scientific purposes or scientific analysis for complex problems like Fourier transformations, like optimization. This library is getting used. From SciPy library is a big library, and from there I'm importing just a small library called stats. And the stats library is going to have all the statistical functions what you can think of. So if you write dir of stats, you'll simply see all the statistical operations. You can see so many of them. Many of them you might have heard of, like kurtosis, like mean, like deviation, division, displacement, and many other, like so many are there which are statistically used in the real-time problems. So you just need to call the function and just need to pass the data into it and the answer will be there. So you can simply create a numpy library, import a numpy library for numerical analysis, and simply say array. In the numpy library we have arrays, and you say numpy dot array, and you pass some values 10, 20, 30, 40, and you can simply say array dot mean, you get a mean value. Array dot sum, you get a sum value. Array dot min, so it's a small array we have taken. You can pass millions of values there. Array dot max, you can get the maximum value. array dot standard deviation, you get the standard deviation for the particular values. So you can see these direct inbuilt functions made life really easy for the programmer. You don't have to do statistically all the operations. You just need to call the functions and things are done. So it is very extensive support in library. As I said, 65,000 libraries. It has got an integration feature. You can integrate your Python code with a .NET code, with a Java code, with a C++ code or C code. It improves the programmer's productivity. If you're writing less number of lines of code, you need a less storage space, you need a less maintenance, less quality assurance, and obviously productivity of a programmer is going to improve. It is very much robust in nature. It is very much scalable. You can write 10 lines of code to the millions of lines of code. Maintenance is really not required because everybody worldwide is going to follow certain rule for writing the Python code. There is a rule of indentation. If you start any block, you need to give one indentation, one tab. Like in other programming languages like C, you have to give curly braces. Suppose you write any function, you need to give curly braces to signify that, okay, this is a function. In Python, we don't have to give that. Now, it is going to improve the program portability. So program written in Unix and Linux can be transported to the Windows and Ubuntu operating system. So it is very much portable in nature. It is interactive, interpreted, and dynamic in nature. You can do functional programming. You can define one function in one file, and you can call that file and import that function directly. You don't have to rewrite the piece of code. Suppose you write a function for summing two numbers, you can write down in one code and call that code in another code and reuse that function. So you don't have to rewrite the piece of code. It is very much object-oriented programming language, wherein we can define classes, we can define different objects, inheritance, polymorphism, encapsulation, all these things can be achieved. Guys, request you to please do not pop in the chat window because I'm getting distracted. I'll give you time to ask questions. So maybe the internet connectivity issues are there with some people. So that's the reason they might be having some disturbance in the voice. Now, if you talk about a job trends for Python with machine learning, so you can see there is a tremendous increase in the job requirements in the Python in the last 4 to 5 years. So if you see, Python is on the top with more than 85% jobs are there in the market for Python only. And apart from that, nowadays, if you see Indeed trends, you will see a lot of requirements are there for the data scientist, and it has been estimated there is more than 10 billion data scientists required by the year end 2020. So there's a huge demand in the market, and definitely people who are good in Python and machine learning and deep learning concepts will easily fetch the job. This is the Google trend for Python requirements. So you can see there is a maximum demand for Python. If you see the graph, more than 99 jobs are there in the Python as compared to PHP, Scala, Ruby, and R programming. Now, if you talk about a difference between Python and R, both are compatible language. I am not going to say R is not a good programming language. I personally feel R gives a very beautiful graphs as compared to Python. But there is a major difference in Python and R is that Python is like a Pacific Ocean, R is like an Indian Ocean. Python has got 65,000 libraries, R is not having those many libraries. Python is called as a king of data science and programming language, but R is called a golden child of data science. Python is a general purpose language which is known for its simple syntax, compatibility with different operating systems. But R is an open source programming language very beneficial for statistical computing. So if you are working in a telecom domain and you want to create some report, how the sale trends are going, you can create a report in R very easily and share it within the email within the organization. But if you want to develop a front end, if I ask you to develop a front end where users can interact, they can give the user ID and password, and using web application, they can submit some request and get some request that you cannot do through R. So R is generally used by the companies who want to generate reports within the organization. They are not into development in terms of user interaction. Suppose like Amazon website. So Amazon website has got millions of products and people are choosing and adding to cart and giving the payments and then getting the delivery. So this complete automated system can be developed only in Python, but not in R programming, because R is a statistical tool for analyzing the data. But Python has a libraries for front-end development, like Teak inter libraries for front-end development. For connecting to the database, we have SQLite 3 library. For connecting to AWS server, we have Boto 3 library. So Python can connect to any of the external sources. It can develop a front end. It can do network programming. It can do front end programming. It can do back end programming, middleware programming. So Python is a complete programming language end to end, but R is called as a statistical tool. Python is popular because of its broadness, efficient, extensible, and it can be mastered easily. So syntactically, I personally feel Python is easier as compared to R. R is also easy programming language, but syntactically little bit difficult as compared to Python. R is an open source, has its analysis toolkit. It is robust and powerful package ecosystem. Python has got a popular libraries like NumPy, SciPy, Pandas, and Matplotlib, which are frequently used for data analytics. NumPy is a library for numerical analysis, for working on statistical data, statistical analysis. SciPy is for scientific processes. Matplotlib is for plotting beautiful graphs. Suppose you want to plot a bar chart, histogram, and other kinds of a graph. Matplotlib is quite popular. Pandas is for data analytics. If you want to extract data from a CSV file, import into Pandas data frame, then you can wrangle the data, munge it, cleanse it, merge it, concatenate it, and send it back to the CSV file. You can do it. Similarly, R has a caret, stinger, and a ggplot libraries for plotting graphs. Python is generally used for developing big applications, like Dropbox is written in Python programming, having more than 170 million users worldwide. Various plugins for Python is created in Python. R programming is widely used in industries which has usually data-driven decision support within the organization for statistical analysis. And Zillow uses R programming to promote prices. So if you talk in short, Python is something which can do end-to-end development, but R is used for statistical analysis, for numerical analysis within the organization, and it can do end-to-end programming. Now, if you talk about evolution of the future of machines, in the older times, if you talk about 30 years back or 25 years back, people were struggling to find a good hardware. We were having a big desktops, we were having a laptops which are very heavy ones, and at that time we were looking for a technology wherein we have a sleek machines where the processing speed should increase, processing power of the machine should be higher, storage space should be higher. So initially floppy disks were there, then floppy disks were replaced by the CD-ROMs, then CD read-write ROMs, then the pen drive came, and technology advances slowly and gradually toward the hardware side. So if you talk about 25 years back, people were more worried about the hardware capabilities rather than data-driven capabilities. Because of the explosion in data, like because of explosion, why I'm saying explosion? Because every minute Facebook server hits with 1 terabytes of data. And imagine every minute 1 TB data is hitting the Facebook server. No hardware or no processor can process that kind of huge amount of data. And that's the reason from the hardware perspective to the data-driven perspective, the angles got changed. People were more worried about the terabytes of data rather than the hardware capabilities. Then they developed the Hadoop system and the Spark system, which were capable of handling terabytes of data. And before that, there were mainframes. Now mainframe demand is not there, but 10 years back, mainframe demand was very high because mainframes can handle terabytes of data. But now Hadoop and Spark ecosystems are there, which can handle it. Then once data-driven technology is there, when the hardware is there, people are thinking of making machines more smart, which are mimicking human behavior. So today's era wherein we are thinking of making machines smart enough to understand what we are trying to say. And you have a lot of visual examples in front of you, like Alexa, Google Dot. You speak in front of Alexa, Alexa takes decisions for you. If you say Alexa, book a cab for me, Alexa books a cab for you. You order something from the Pizza Hut, Alexa do it. You ask for a song, Alexa gives the answer. You ask a question from Alexa, Alexa gives it. So it is more of a mimicking human behavior. And our trend is like that. We are looking for something machines which are more smarter than human beings in developing or testing their own softwares. And that is the era of machine learning, wherein we are doing predictive analysis. Now, if you talk about the history of artificial intelligence came into existence in 1956 when the word artificial intelligence was coined. AI is a field wherein we are trying to mimic human behavior. And the first algorithm for AI was a perceptron algorithm, which was perceptron for network analysis for transferring data packets from one machine to another. So AI is a field. In the broader terms, it is something which is mimicking human behavior. For example, you take a blood drop and give it to a machine. Machine is going to give all the statistical details about the blood. What is a blood group? What is a RBC count, WBC count, and so on. So machines are mimicking human behavior. Previously, people used to do it through its own by using microscope. Now, machine is doing it. So artificial intelligence is any area which is mimicking human behavior, like robotics, like bioinformatics, like genetics, or you can say anything which is trying to save human time in terms of taking decisions is known as artificial intelligence. Now, why this artificial intelligence is required? Because obviously, if you talk about Amazon website and millions of users are ordering at certain point of time, and millions of users get recommendation as well. Suppose you are a user who do not buy more than 10,000 bucks of product, so Amazon is not going to recommend you an Apple iPhone of 1 lakh rupees. Definitely it is not going to do that, because they know that you are not going to buy it. Suppose you are staying in a very colder region, they are not going to give you a recommendation of a refrigerator. Suppose you are watching a movie on Netflix, mostly thriller movies, so Netflix is going to recommend you thriller movies based on the liking from the other user. They are not going to give you comedy movies. So this thing has to be automated, because millions of users are buying online. You cannot have millions of users recommendation manually driven. Even if you have a team of 1,000 people, they cannot manually give recommendation to millions of users. It's humanly not possible. And that is the reason, because of the data explosion, we need some technology which is smart enough to think like a human and take some decisions from the human behalf and give it to the end user. Like Amazon, Flipkart, Snapdeal, Netflix, Prime Video, all these are doing it. And you can see why the data explosion is there. There are 204 emails sent on a everyday basis, 20 new victims identified threat. Every minute I'm talking about 204 million emails, 20 new victims identified threat, 47,000 apps get downloaded, 277,000 logins, 6 million Facebook views, 2 plus million search queries, and which is beyond human capabilities to process that huge amount of data. And that is the reason Hadoop and Spark systems are used along with Python and R programming to make it more possible. Now, what is the difference between artificial intelligence, machine learning, and deep learning? So I'll give you the brief idea about it. What is the difference between them? So if we talk about a data science is a broad area which consists of all these things: artificial intelligence, machine learning, deep learning, data analytics. So anything pertaining to data. So when you say data, data is something which is a raw data. A data can be an email, data can be a text, data can be a CSV file, data can be a feather file, Packet file, HTML document, anything which is useful for humans in terms of taking decisions as a raw data. We call it as a data. Now, data science is an area which is able to process that data for taking some information. Artificial intelligence is a subset of data science which is mimicking human behavior. When you try to mimic human behavior, it comes in the umbrella of artificial intelligence, like bioinformatics, like robotics, genetics, like all the areas which are trying to mimic all the machineries which are trying to mimic human behavior under the umbrella of artificial intelligence. Machine learning is a subset of AI which is talking about predictive analysis. For example, if I give you a last 20 years data of humidity, rainfall, temperature, and crop yield, and if I'll ask you what is going to be the crop yield in 2020 December, and machine is going to predict it, it is called a machine learning application. For example, when you book a cab from Ola and Uber, you come to know in how much time your cab is going to reach your destination. What is this? This is predictive analysis. You're predicting in how much time the cab is going to reach you. When you book the cab, when you sit in the cab, when you're going to office, you come to know in how much time I'll be reaching the destination. So you're doing predictions. You are finding out the predictions. Similarly, when you go to Amazon or Flipkart, you order something, Amazon server is automatically give you some predictions that this person can buy this product as well. Suppose you buy a mobile, it is going to recommend you mobile cover and a temper glass. It's a recommendation. What it is doing, it is doing predictive analysis. After buying this product, what next product a person can buy, and with a great accuracy they are going to predict it. When you watch a movie on Netflix, system is predicting this person can buy this person can view another movie because it is of similar type. When you are talking to Alexa, Alexa is predicting what you are saying with a great accuracy and taking the action. So machine learning is nothing but a subset of artificial intelligence which is primarily doing predictive analysis, predicting the future based on historical data. Now, if you talk about deep learning is a subset of ML which is again doing predictions but on a larger scale in terms of high dimensionality of a data. For example, if you have a images which is having a red, blue, and green pixels, and you want to predict something, whether new image is going to be in which category. Suppose you make the machine learn using your algorithm that this is the image of a dog and this is the image of a cat, and next time you supply a new image of new animal, system can predict whether it's a dog or a cat. So deep learning is an area which works on higher dimensional data, high dimensionality of a data, like images, like text translation, like voice translation, like image colorization. Suppose you supply any black and white image to a machine knows, okay, this is a bird and this is a sparrow, it is going to color it with a sparrow color. So deep learning is an area which again machine learning can do, but again machine learning requires more energy to do that. More energy in terms of programmer's time or data engineer time or data analyst time. In terms of feature extraction, suppose you have thousands of columns and you want to filter out which columns are really important for my decision, this is the job of a data scientist in machine learning. For example, humidity, rainfall, temperature. These are the important columns for crop yield. But if you add how many children a farmer is having, this is not an important column for crop yield. So what you'll do, you'll drop the column. You'll drop the column how many children farmer is having, and then feed in this data to a machine learning algorithm. So this feature extraction is a job of data scientist in machine learning. Suppose there's a column where the variance is very low. Suppose there's a column called age, where every age is 24 years. This column is not contributing to the result, obviously. So you're going to drop it. Suppose there's one column where a lot of missing values are there. Missing value ratio is very high. You are going to drop that column because it is not contributing to the result. So in machine learning, feature extraction is a job of data scientists. Feature extraction means column extraction, which are really important for decision making. But in deep learning, feature extraction is automatic. You don't have to decline any column or drop any column. You feed in blindly the whole data and system automatically recognizes it. And deep learning is a concept given by Google. And this concept is quite, you can say, like a black box. Google has not disclosed the algorithms completely. We know these are the neural networks and this is how the data flows from one network to another, but we do not know completely the algorithm behind it. But in machine learning, we know the algorithms completely. If I talk about linear regression, we know what is y equal to mx plus c. We know what is the linear regression equation. We know what is logistic regression, what are log it, what are log of odds, what is sigmoid curve, what is Gaussian distribution. We know everything about machine learning. But in deep learning, it's again a black box. We do not have a complete idea about algorithms running behind it. And the popular libraries for deep learning is TensorFlow and Keras. So I'll give you 5 minutes time. You can ask questions to me or raise your hand. I'll unmute you. I think up till here all are clear. So Go is again a new language which is very quite getting popular, but it is not as popular as Python. Python is more popular these days. Maybe happens, Swagat may happen that Go can replace Python. May happen like that. Now, what is data science? Data science is a broad term for multiple disciplines. Machine learning fits with data science. So as I told you, as I explained in the previous slide, machine learning is a subset of, or AI is a subset of data science, and ML is a subset of AI. So data science is a bigger domain which talks about multiple disciplines. Machine learning uses various techniques like regression and supervised clustering. On the other hand, data and data science may or not evolve the machine learning or mechanical processes. So data science may or may not go to the predictive analysis. You can just stop at analytics. You can just stop at business analysis. You can stop at statistical patterns. You can stop at database processing. You can stop at data mining. So if you see this right hand side diagram, data science is a multidisciplinary area which consists of machine learning, data mining, database processing, visualizations in terms of graphs, statistical patterns, pattern recognition, artificial intelligence. So anything which is pertaining to data when comes into picture, we are talking about data science. So the main difference between the two is that data science is a broader term and not only focuses on algorithm and statistics, but also takes care of entire data processing methodology. So data science, if we talk about, it is a complete end-to-end process, fetching the data from the external source, processing it, merging it, cleaning it, changing it, and then finally sending it to the repository and storing it and maintaining it. So data science is a bigger domain which consists of handling data from end to end. So if we talk about data science method, first of all, we formulate a question: what is a business understanding and analytical approach? The second step is to gather the data to answer that question. So we have data requirements, data collection, data understanding, and data preparation. So data collection can be from a database, from external sources, from HTML websites, using web scraping. And once we gather the data, we analyze it for modeling and evaluation. We model it means we create some models which can understand data quite quickly, cleanse the data automatically, and finally evaluate it. And once we evaluate the data, we generally give a product as a feedback or a deployment, which is in terms of decision making. So data science methodology is broadly classified into 4 areas. First of all, formulate a question, then gather the data from the external source, then analyze the data, plot the graph, visualize it, and then finally deliver the product as a decision making. Now, there are two approaches of data science. One is called top-down approach, wherein we have a business problem, we dig into the business problem to solve the answer. For that, we should have a domain knowledge. So let's say I have a telecom domain experience, and my question is how many new telecom users are going to be in near future. So first of all, I should know the telecom complete domain knowledge, who people are using it, what is the telecom technology we are using it, what front end and back end we are using, and then we gather the information to answer that query. And then from the data and facts we use for problem solving. So that is a top-down approach when we have a problem in hand and we come to the solution by granularly coming down to the tree. In the bottom-up approach, we have a data there with us. We don't know what to do. For example, Amazon has a lot of data. They have a KYC detail, they have a buying history detail, they have your location detail, they have your product history detail, what products you have bought. They have other details in terms of what maximum amount you go for buying a particular product, or what frequent item you're buying, whether you're buying electronic items or you're buying consumer goods. So in the bottom up approach, we have a huge amount of data, but we don't know what to take, what to look it forward. And in that case, we create an information out of it. And then using our domain knowledge, we help in problem solving. So if I found a customer who are more frequently use consumer products, I will formulate a question, then using my domain knowledge, what next product he may buy. Suppose somebody buys a bread, my intention is to offer him to butter or some eatable products. So recommendation engine works in this way, which is working like a bottom-up approach, looking at the history of the consumer, looking at the past purchases. We are recommending something to the end user. So in data science approach, top-down approach, looking from the problem till solution, and from data science bottom-up approach, we have a data in hand and we come to the problem solution by giving it to the end user. So there are two basic approaches in data science. So depending on the nature, we use it. If we talk about how machine learning can add values to different business sectors, so the bigger the circle you see, size of the bubble indicates variety of data, number of data types. So the bigger circle means it is using more extensively, and the smaller circle means it is not using multiple variables over there. So if you see, a lot of data has been used in media and telecom industry. So if you see this blue color circle, this telecom industry is using machine learning quite extensively. Similarly, media is using and finance is using machine learning quite extensively. So all these blue colors are majorly given over here. Even in purple colors like healthcare sector, pharmaceuticals are using machine learning for predictive analysis. So these areas like diagnosing a disease, like predicting the maintenance energy, finding out the personalized financial products, identify and navigate roads, optimize merchandise strategy. So all these areas have been using frequency of the data is from low priority to the high priority. And if you see, the high priority data is getting used majorly into areas of finance, automobile, media, telecom, healthcare, pharmaceutical, and consumer products. Now, if you talk about machine learning with great impact potential across industries and this use case, so if you see, the darker color of green shows the more impact in the industry. So if you talk about this agriculture, finance, consumer, manufacturing, and automotive industry, there is a lot of strategic optimizations or decisions have been taken using machine learning. A lot of predictions are made using in consumer products using machine learning. Similarly, a lot of transport and logistic decisions are taken using predictive analysis. Similarly, for forecasting, we use majorly machine learning for forecasting. Similarly, for discovering trends and anomalies, anomaly detection is what? For example, if you're using a credit card and your spending in a month is not more than 10,000 bucks, and one day you swipe a card with 2 lakh rupees, what happens? The bank is going to call you. Is there any fraud, or is it a right transaction? So anomaly detection is a task of machine learning and which is quite extensively used in the industry. Now, if you talk about Netflix, Netflix is recommending the movie to you depending on the use, depending on the visual, whatever the movies you have viewed in the past. Let's say you're viewing thriller movies most of the time, that it is going to recommend you thriller movies. So over 75% of what you watch in recommendations is given by Netflix. Recommendations are made by machine learning. Similarly, if you talk about Facebook tags, you just move a pointer to the face of a person and automatically the tag will come that this person name is this. That is face recognition, and it is driven by the deep learning algorithms. So deep learning algorithms recognize the face. For example, if you go to Dubai airport, you don't have to show your visa and the passport and all those things. By eye retina scan, they come to know what is your KYC details. Similarly, if you talk about Amazon Alexa, you just say, Alexa, what needs to be done to turn off the light, or to start the car engine, or to go to book a car, or you need to order a pizza, or you need to order any song. You simply need to just give an instruction to the Alexa device. Alexa do predictive analysis, converting your text to a natural language processing to a context-free grammar, creating an algorithm, using the algorithm as an inbuilt algorithm, maybe random forest, and then taking decisions with a great accuracy, and the action has been taken. So all these things are done by Google Dot or Alexa. Similarly, email filtering. So you might have observed in Gmail, all your spam folder will have a spam emails which are not useful to you. So depending on the keywords like lottery, depending on the keywords like you won this prize, it is doing the spam mail detection and automatically putting into the spam folder. So in the older times, the spamming was not there, so you get hundreds of emails in a day, which are quite useless to you. So all these things are done by machine learning algorithm. So machine learning is a future of industry which is a demand for today, and more than 2 million jobs globally by the end of 2019. And again, as I said, more than 10 million jobs by 2020 end. So what is machine learning? Machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically and improve with experience without being explicitly programmed. So let me explain you this definition. We all know it's a subset of AI which is doing predictive analysis. So it provides machine ability to learn automatically. What do you mean by learn automatically? It's basically, this definition is for the end user. Let's say I'm a new to computers. I do not know computers. I'm a mature person. And if I ask machine what is going to be the crop yield in 2020 December, and machine says the crop yield is going to be 100 tons, I am 95% accurate. What you'll think? You'll think that machine has got a thinking power. So this definition is for basically end user, which says machine has got a capability to learn automatically from the historical data. Improve by experience means more and more data you provide, the more and more better decisions you are going to get. And without being explicitly programmed means you don't have to do programming again and again. So for example, if I made a linear regression program and I create an equation y equal to mx plus c, y is a dependent variable, m is a slope, x is an independent variable, and c is an intercept. And again, if I supply x value, I get a predicted y value. And we can do cross validation to prove this accuracy is good or bad. So for the end user, it looks like the machine has got a capability to learn on its own and give a predictions with a great accuracy. But it is not learning on its own. We are giving the algorithm to learn it. From the historical data, we are trying to create an equation between the independent and dependent variable so that we can use that equation for future predictions. So what you're doing, you're trying to use algorithms like linear regression, like logistic regression, like random forest, decision trees, naive-bayes classifier to find out the relation between independent and dependent variables. And once this relationship had been established in the form of a mathematical equation, you can use this equation to provide x value to get the y value. And then you cross validate it whether it's good or bad. So machine learning is a subset of AI which is doing predictive analysis, and code has to be changed. Only data has to be supplied more and more. So your code is not going to change in machine learning. The code remains same, but you are supplying more and more data in the future. Now, what are the different types of machine learning? Basically, there are three types of machine learning: supervised, unsupervised, and reinforcement learning. There are three types of machine learning. Let me explain you in detail what are the different types of machine learning. So if you talk about machine learning, there are basically three types of machine learning: supervised, so unsupervised, and reinforcement. Now let me explain you what is supervised machine learning. Supervised machine learning is the one where we know the column headings completely, or we know our data completely. We can say we know our data completely, or we can say we know column labels. So for example, if I give you a telecom data and if I give you the customer name, customer age, customer date of birth, customer calling details, his location and everything, you know what column is talking about what. So we have different supervised machine learning algorithms, like we have linear regression, we have random forest, we have decision trees, we have logistic regression, we have naive-bayes classifier. So they're used on different types of data. So all the algorithms are good algorithms. Only thing is it depends on the type of data we are using it. For example, linear regression is used when the data is continuous. Logistic regression is used when the dependent variable is categorical in nature. Unsupervised machine learning is where we do not know the data completely. For example, when we do not know data completely means we do not know column headings. So one of the typical examples of this is, let's say an archaeologist finds a bone deep inside the earth. what he'll do, he'll find the texture of the bone, color of the bone, shape of the bone, size of the bone, and matches with the historical data. So here we find hidden features in data. For example, a preschool kid, if you give different shapes and colors, what he'll do, he do not know what is green color, what is blue color, what is yellow color, but still he can segregate based on the colors, similarity of the colors. So here we find the similarities in the hidden features, and based on that we do clustering. So here we do clustering. For example, the algorithms are k-means clustering. We can use agglomerative clustering. We can use c-means clustering. So different algorithms are there in unsupervised learning. Reinforcement learning is an area which is learning with experience. Learning with experience, we have a famous Maslow's dog theory here. So what Maslow has got, he has got a dog and he used to daily feed that dog. So one day he started thinking, okay, why not to ring a bell and give a food to a dog and convert his natural stimulus to induced stimulus. So he rings a bell, give a food to a dog. He rings a bell, give a food to a dog, and for the continuous 10 days, he rings a bell and then give a food to a dog. On the 11th day, what happens? As soon as he rings the bell, the dog starts salivating, and he converted the natural stimulus to an induced stimulus. So what happened? It's a slow and gradual development. Similarly, a manless car. If you talk about a Tesla manless car, so what scientists have done? They have given hundreds and hundreds of images on a daily basis to this car and done it in a simulated environment. When the car hits an accident or meets an accident, it's a penalty, and when the car is moving smoothly, it's a reward. So based on reward and penalty, it creates an algorithm in such a way for penalty, it gives some policies so that this mistake cannot be repeated. And slowly and gradually, by supplying hundreds and hundreds of images on a daily basis, a time has come where millions of images car knows and takes a decisions, corrective actions, like a Google map. So if you might have remembered, like around 10 years back, Google used to ask us, we as a users, mark down your home, mark down the Pizza Hut nearby, mark down the store nearby. And today you can see Google Maps is mature enough, they know every road, every shop, every store. So that's a reinforcement learning, learning with experience, slow and gradual learning, and becoming mature. A lot of gaming programs you might have observed. Initially, the gaming programs are quite easy for you, but slowly and gradually they becomes harder and harder depending on your expertise level. So these are all reinforcement learning examples. Alexa device. So if you buy a new Alexa device, if you speak in front of Alexa, you might have observed Alexa is not understanding every word of yours, but slowly and gradually, when you keep on talking to Alexa, Alexa knows you better. And another example can be Apple iPhone. You might have observed Apple iPhone in today's technology. When you daily suppose wake up in the morning and see your emails as a first thing, and you want to keep up the reminders for the same. So in Apple iPhone, you don't have to keep the reminder. Phone knows automatically at 7 a.m. You are opening an email. So if you continuously do this trend, Apple automatically opens the email in front of you. So that is reinforcement learning, learning with experience. There is no as such algorithm in it. Depending on the domain, depending on the areas, reinforcement learning has been implemented. So there's a different theories over there, like Markov's theory, differentiating theory. So there are different theories in deep in this reinforcement learning. So let's discuss in detail. In supervised learning is where you have an input variable X, we have output variable Y, we know the data completely, and your algorithm is going to map the independent variable with a dependent variable. Suppose you have some raw input, you take algorithm, you model it, you pass on the data to the algorithm fits in the data, find the relationship between them, and once the model is created, you're going to test it for a new data, whether it's going to be a apple or a mango. So any kind of a categorization or any kind of a classification can be done. Supervised learning is examples can be linear regression when the data is continuous, or it can be categorical in nature. If it is categorical, we use logistic regression, random forest, and decision trees. It is called supervised because the process of an algorithm learning from the training data set can be thought as a teacher supervising the learning process. So this algorithm is going to learn from the historical data, what are the trends, what is the relationship between them, and based on that, create an equation internally and use the same equation for future predictions. The second is the example of this is suppose you feed in the images of a duck and not a duck, and supervised machine learning algorithm is going to learn from the historical data which is duck and which is not, and create a predictive model which is predicting the future. When the new image comes, whether it's a duck or not, if it is going to give the right predictions. Now, supervised machine learning use cases can be document classification, whether the email is a spam email or not, or whether a document is going to be a Word doc or an Excel doc or a PDF doc, depending on the type of extension and type of content, system is classifying it in the right categories. Another can be a weather prediction. Suppose you are supplying a data for the last 20 years of humidity, rainfall, and other environmental factors, and you can predict what is going to be the temperature tomorrow. So generally we use decision trees in these kind of areas wherein we have continuous data in the dependent variable. So we can use decision tree regressor. So there are two types of algorithm, regressor and classifier. So there are two algorithm, decision tree regressor, similarly decision tree classifier. Similarly, we have random forest classifier and random forest regressor. So random forest is nothing but a collection of decision trees. So predictive analysis is done using weather prediction using supervised machine learning algorithms. Similarly, fingerprint analysis, which is again a three-dimensional data in a form of a pixel of red, blue, green images, or maybe a binary data. So fingerprint analysis is again a task of a supervised machine learning algorithm. And various popular supervised machine learning algorithms are linear regression, logistic regression, decision trees, random forest, and naive-based classifier. So unsupervised learning is a training of a model using information that is neither classified nor labeled. Unsupervised learning is also known as the clustering analysis. So as I told you, in unsupervised, we do not know the column headings. We do not know what exactly data is talking about. We find the similarities in the data. We don't have a dependent variable here. We just have a data in front of us. For example, in the banking domain, we know the amount or the balances in the account. And based on the debit and credit history, we are going to cluster customers based on their history. People having the high spending and high earning, they are classified as one cluster. People other than that are classified in other cluster, and we are going to offer a credit card to the people who are having high earning and high spending. So machine learning, unsupervised machine learning algorithm is going to find the similarities in the data structures and classify it. So maybe depending on the shape, maybe depending on the color, maybe depending on the features, maybe depending on the teeth. So depending on the similarities, it is going to cluster it into different clusters. And the use case is a party in the house. So for example, there's a party going on in the house and there's a singer who is singing and you do not know the name of a singer. What you'll do? You'll just recognize the voice and predict, okay, this singer is this one. So without looking at the face of a singer, you can predict who singer it is by looking at the similarities in the voice or by recognizing the voice. So voice is what? Voice is listening to you, the face is hidden from you. So even if the face is not shown, you can recognize the singer. And that is unsupervised learning. Similarly, in the football match, you do not know which team is playing what. So based on the similarities of their shirt, you can find out, okay, these players are on one side and these players are on the other side. Maybe you do not know the football game, but still you can figure it out whose team is playing against whom. Similarly, the recommendation engines do not know what product it is, whether it's a consumable product or whether it's an electronic product or electronic item or any kind of a cosmetic item. But based on the history of the customer, it is classifying it the categories of a products. For example, a consumer products are categorized into one, for electronic products are classified into another. So recommendation engines are recommending based on the similarities. Suppose somebody buy a mobile phone, so all the accessories related to mobile phone are clustered as a single cluster and saying that mobile temper glass or mobile cover is one of the clusters we are going to recommend. So various algorithms for unsupervised machine learning can be k-means algorithm, a priori algorithm. So a priori can be used for both supervised and unsupervised. Hierarchical clustering and k nearest neighbor. K nearest neighbor is basically used for supervised majorly, and they can be agglomerative clustering, again known as hierarchical clustering, and C-means clustering. Third type of area is a reinforcement learning. It's an area of machine learning where reinforcement agent means computer, learns from the consequences of its action. So in a simulated environment, when you're in a car in a simulated environment, so system is learning when the accident happens and when it does not happen. And when the accident happens, we provide some policy that if you see a red light, you need to stop there, and next time it will not repeat. Rather than being taught explicitly, so system is not taught explicitly means we are not going to give the rules automatically, but based on system performance, we are going to give corrective actions. It selects its action on the basis of past experiences known as exploitation and making new choices called exploration. So what is exploitation and exploration? For example, you get transferred to a new place and you need to go to the office, and you choose one path, one road, and you find the road is quite congested. So next day you'll not take that path, you'll explore new path. You find a new road where no traffic is there, and you try to exploit that path again and again. You again go from the same path and you exploit it till the time the traffic is going to be there. And once again, when the traffic is there, you explore some other path. So reinforcement learning algorithms are working on exploitation and exploration policies, wherein if you are getting the good results in one strategy, you are going to exploit it. If you're not getting results, you are going to explore new opportunities. So reinforcement learning, we don't have any as such algorithm, but the Pavlov's or the Maslow's dog theory. So some people say it's a Pavlov's dog theory, some people say it's a Maslow's dog theory, wherein we are turning the natural stimulus to induced stimulus. We provide a food to a dog and dog starts salivating. Next time we ring a bell and give a food to a dog. Dog do not salivate, but keep on doing giving the food to a dog and ring a bell and keep on doing for 10 days. And even if you ring a bell on the 11th day, dog starts salivating. So what you converted? You converted the natural stimulus to an induced stimulus. So what we can do with machine learning, we can do a lot of things. We can find the market value of the house based on the historical data. We can find out whether the email is spam or not. We can find any fraudulent transactions and outliers in the data. We can find house lies in which segment, which customer segment. We are going to find out the hotel lies in which category. It's a 2-star, 3-star, or 4-star. We are going to find out whether the person is going to win the election or not based on the historical data. We are going to find out the text translation, giving the text in a German and converting to an English language with a great accuracy. We are going to do the image recognition, image colorization, text translation. So all these are the areas of machine learning only. Now, what are the use cases of machine learning? So classification algorithms are going to classify whether the person is a male or female based on the physical appearances. It is going to classify whether the male is spam or not a spam. In the healthcare domain, we can find whether the person is having a cancer which is benign or malignant. Suppose you supply 100 uh, reports of a person having benign cancer or malignant cancer, and system can find out from the independent variables based on the values there, a person is having a benign cancer or a malignant cancer. So generally we use logistic regression in this. Similarly, in the retail sector, we can classification of high and less selling products in the market basket analysis. So market basket analysis is nothing but finding an association rule between the products, and there are matrices like support, confidence, and lift over there. Support says how both the items are selling together, what is the frequency. Confidence says if one item is sold, what is the probability other is also sold, and that order matters. Suppose somebody buy a car, there's a very high probability he'll buy the perfume as well, but vice versa is not true. Somebody buy a perfume, there's a very less probability he'll buy a car. So confidence says if somebody buys one product, what is the probability he'll buy some other product. So these are the matrices in retail sector wherein we use market basket analysis, and there's an inbuilt algorithm in Python called a priori, APRORI. Similarly, we can find the anomaly detection. Is there any fraud in the transaction or not? As an example, I told you, if you are swiping a card for 10,000 bucks in a particular day, and someday you swipe it for 5 lakh or 2 lakh rupees, automatically call comes to you, which is like an outlier. So fraudulent transactions can be easily detected. If someone is trying to hack our network or not, all these anomaly detections can be done using machine learning. In telecom domain, we can find out the fraudulent calls. We can use regression algorithms to find the market value of the house based on the historical data. Whether it's going to be rainy day or tomorrow or not, based on the historical data, we can predict it. We can use clustering algorithms to find which house lies in which segment, what type of customer buys which product. So based on the historical data of yours, when you're buying a high-end products or expensive products, system is going to recommend you expensive products and not the products of general range. Areas of reinforcement learning is automotive industry is a manless car, and it has already been implemented called Tesla. In aerodynamics industry, it's already been implemented. You see all the planes are running in the autopilot mode. They know at what height they are running and what humidity is there outside, what rainfall is there, and taking the actions automatically without human interventions, because human can think only in 1 or 2 dimensions, but machines can think on hundreds of dimensions. In the manufacturing industry, robotics getting mature for faster manufacturing. So robots are getting mature day by day. So AI and machine learning a potential advantage in the banking domain, banking and financial sector domain. We have resource management, we have a front office optimization, we have a predictive analysis for risk management, operational market credit and business risk management. We have new patterns for pricing, research, market business trends. We have a personalization for the customer. So you might have observed in today's world in ICICI Bank, your dashboard is customized as per your need. So we got a customized 101 customer kind of a customer and banking relation domain. You can see 101 approach, like a dedicated website for you where you have a dashboard which you like to see. So all these things are developed by machine learning applications. So generally from quantitative and structured data, we get a qualitative and destructured data. We move on from a point where the data is driven by the web, where driven by the banking sector. Now it is driven by the customer itself. If you want to see the portfolio, he can see it every time as a first screen. If you want to see the balances, he can see it. So you can give a customized approach to the end customer. So if you see the clustering use cases, you can use it in marketing, discovering distinct groups of customer databases, such as customers who make a lot of long distance calls. And generally you market the more lucrative plans to the people who are giving more long distance calls. For the insurance industries, you can find the high risk customers and low risk customers, whether to approve the loan or insurance to them or not. Identify groups of crop insurance policyholders with a high average claim rate, farmers with a cash crop when it is profitable. You can find out the land use, identification of areas similar to land use by GIS database. For seismic studies, you can use it for gas and oil exploitations. Similarly, Google News can be used for machine learning for classifying the news pertaining to some celebrity. So you can have a big document having millions of times. Let's say Donald Trump is coming and you want to classify the document whether it's related to Donald Trump or Narendra Modi. You can simply do natural language processing. NLT can classify the document as per the frequency of the words given over there. You can find out the price of the house, or you can find out where to open the school based on clustering algorithms, based on the population, whether the population of older age group is staying there, or a new generation is there, or the kids are there. So you can find out using clustering algorithms what is the best area to open the school, and you can identify the locations. Similarly, for the image recognition, you can find out the facial recognition of a person. You can figure it out, the facial dimensions of a figure in a red, blue, and green pixels, and deep learning algorithms are using it for predictive analysis. So all deep learning algorithms are capable of handling three-dimensional data. Even machine learning can do by using dimensionality reduction. The algorithms in machine learning called PC and LDA, principal component analysis and linear discriminant analysis, which do dimensional reduction. So you can do that, but majorly it is done using deep learning algorithms. Text translation, you have a word in different language, you can convert to English by using text translation. So what is deep learning? Deep learning is a particular kind of a machine learning that achieves greater power and flexibility by learning to represent the world as a nested hierarchy of concepts or abstractions. So we have different neural networks over there, neural nets, or a network layer made up of neurons. And we use different algorithms for activation like ReLU, like softmax, and different algorithms over there to understand the images in a better manner. So we have different types of deep learning algorithms like convolutional deep learning algorithms or recurrent neural networks. So convolutional neural networks is for image recognition. RNN is used for text translations. So example of a deep learning algorithm automatically finds the features which are really important or which are not. That the square has a side 4, it is a closed type, it is perpendicular, equal size. So it look at the particular image and find out all the particular hidden features in the particular data. So for the unsupervised learning, we have encoders in deep learning which understands the unstructured data. Now, if we talk about deep learning for image recognition, we have different input layer. We have an input layer, we supply the input data. We have network layers or the neuron layers wherein we find out the hidden features in the images. And finally, we have an output layer which classifies what type of animal it is. So if we talk about difference in machine learning versus deep learning, as I discussed, machine learning feature extraction is a job of data scientist, but in deep learning, feature extraction is automatic. In machine learning, the complexity of the algorithm is not very high, but in deep learning, it is high. Machine learning codes takes lesser time to execute, but deep learning can take days to learn. It works on forward and backward tracing. So deep learning algorithms are quite expensive in nature in terms of CPU and RAM, but accuracy of a deep learning algorithms are far better than machine learning. So deep learning is a subset of machine learning, or we can say deep learning is nothing but a machine learning. So if we talk about performance and the amount of data, so in deep learning, the performance is really great for a huge amount of data. But in machine learning, we have a limited performance for the high dimensionality of our data. So if we talk about the future of our industry, you are going to see a lot of applications going to implement in the coming 10 years, wherein we have a lot of examples of deep learning. In today's life also, we can see a lot of examples like face recognition, text translation, voice translation, but still it's an area where a lot of development is going on, and deep learning is going to the future of the industry. And definitely the hardware dependency would be required, because deep learning requires GPUs, or uh, like you might have observed in the older systems, we have a separate memory, this display card was a separate device, or a different hardware we need to plug into the motherboard. But nowadays GPUs are there, which are capable of processing the images quite easily. So in today's world, GPUs are inbuilt, but we are looking for more better technologies in deep learning for faster processing. So in the deep learning, we have an input layer, we have a hidden layers where the data get abstracted in different forms, and then finally we have an output layer which says what is the final answer. So if you talk about problem solving approach, so deep learning algorithms are going to find out the image, understands the hidden meaning behind it, convert the text out of it, and finally find out what exactly the image is all about. And we have a famous deep learning algorithms like Julia, like MXNext, K, Theano, CNTK, Cafe2, Chainer, and TensorFlow. So TensorFlow and Keras is one of the popular libraries in deep learning. So we have a training data. So GPUs are using deep learning for creating our models. We have a training data, or training data means data on which we create a model. Once the model is created, deep learning is created, deep learning model is created with different layers. And finally, we inference the model and take a predictions for a new image. So the concept is same like in machine learning. Only thing is the algorithm here in deep learnings are different as compared to machine learning. It works on a different way altogether. Now it's execution time for us to learn all these things, because it's the right time. And if you talk about AI and machine learning analytics and training ecosystem, we have a course portfolio, and these are the areas which are in demand these days. So if you talk about the areas which are in demand these days, is the deep learning, computer vision, image processing, reinforcement learning, robotic process automation, big data analytics, automation anywhere, and all those areas.
Abhay, thank you so much. This has been an insightful session. I have been a part of this all through. And thank you so much for the great examples. Also, attendees, you have been extremely participative and attentive throughout. The responses have been overwhelming. Like Abhay mentioned, there have been thousands of attendees all on this session. So we are not able to attend all the questions. You'll receive a survey form post this, wherein you can drop in any kind of queries and we should be able to get back to you. A lot of people have been concerned about the recording, the certification. So there would be just one answer to it. This session has been recorded, and you'll get it through the email IDs that you have mentioned while registering for this session. And this will take 2 to 3 business days. Same is the case with the certification as well. You'll receive a participation certificate through your email IDs as well. And yeah, we should be good to go there. In case I saw a couple of you asking about training, getting trained on this technology and course, please drop your interest in the survey form, and our teams will be reaching out to you. Alternately, you can reach out to your learning and development teams, because we are partners with you guys and can help you with corporate trainings in a private mode as well. So yeah, that can be facilitated. So once again, thank you so much. And flashing in front of you is the course portfolio that falls under the topic that we covered today. Each of these can be a different course in itself. So yeah, whatever your interest is, please drop in a note and we will be coming back to you with instant help. Okay, with that, we'll take a leave for today's session. Thank you so much, Abhay, one more time. And thank you so much, everybody, for joining in. Please stay safe and indoors. Bye-bye.
Yeah, thank you everyone, and kindly give a feedback like what you are interested in, and definitely if you have some particular queries pertaining to me, you can address over there. I'll definitely get the time and revert you on the email. Thanks for your time. Have a great day. Bye bye and take care.